Okay, some more exercise. First one, circumference of a circle with radius 9 centimeters. Remember, when we have the radius, it's easy to use the formula 2 pi r. We have it here. Now, we apply this. We make a substitution. Now, the radius is 9. We only have to make a substitution here. And then we will get the result. If we have to have it in terms of pi, it's 18 pi. And we need to have the decimal. We only have to multiply using the calculator. Now, another example. We have the radius of a circle with circumference 26 centimeters. Okay? We need the radius. Let's make the substitution again in the same formula. But now it's kind of different because we have the circumference. That means that letter C will be 26. Then we only have to solve for r. Remember, a 2 pi r, we have to divide it in both sides to cancel, and we get 26 divided by 2 pi is equal to r. The radius is equal to 4.14 radius. Because we are talking about meters, the answer is in meters. Now, here we have an example. Here we have several measures in this part. But this is only is a diameter, right? 15 plus 5.5 plus 5.5. Let's find the diameter first. And we have to add it. We get that the diameter is 26 inches. That is the diameter of that tire. Now, we are looking for the revolutions, the distance, the car travel. A revolution is how many times it made a rotation this tire. That means revolution here. When it's a small tire, the revolution will be very small. The advance will be small. It is a big tire. Will be the advance in every revolution will be a big advance. We will make 15 rotations, 15 revolutions. Now, we need the circumference to find the distance. Let's use it when we have the diameter. Circumference times pi times the diameter is the formula we will use. We have the diameter is 26. Now we have the circumference is 81.68. Now, let's see this relation that we have. The distance traveled is equal to the number of revolutions times the circumference. I mean, for every revolution, imagine that we have a circumference of 1 meters. From every revolution, it crosses an advance 1 meter. If we have a tire that has a circumference of 2 meters, for every revolution, 2 meters. In 2 revolutions will be 4, and so on. Now we know that it's 15 revolutions. We know the circumference. Now we only have to multiply if we get this value. That is 12.25 in 0.2 inches. That is the distance traveled here. If we want it in another unit, we only have to make a change with the units. Remember, 1 foot is equal to 12 inches. If we get the result. Now, let's go to the exercise of length of the arc. Now, we have this one that is 68 is the measure of the arc. Remember, the measure is in degrees. We have that 8 centimeter is the radius. If we are looking for this part that is in red. Now, the solution will do applying the formula. But remember, this formula is a proportion, right? 60 is the measure of the angle that we have, the arc length, the measure of the arc, sorry, divided by 360, that is the total of the circle, divided by the circumference, that is 2 pi times 8. 8 because it's the radius, and we get the result. Another example, this one, basically the same thing. EF, applying the formula of the proportion, will be 60 divided by 360, 2 pi times 11, 11.52 centimeters. Find the length of each red arc. Again, the same situation. We have the measure of the arc here. If we have 11.5, it will be 120 divided by 360 times the circumference. Okay, that will be the solution. Now, this is different because we are looking for the circumference in this situation. We don't have the circumference. We have the arc length that is 4.19. We have the measure of the arc that is 40. Now we are looking for the circumference of circle C. Now, here we have again the proportion because that is easier to understand. The arc length, total arc length, is corresponds with the circumference as the measure of the arc with 360. Or if you want to have this in this place and the circumference in this place will be the same. Doesn't matter. Now, let's make a substitution. We have the arc length xy, that is 4.19. If we have the measure of this arc, that is 40. Let's make the substitution. Now we only have to solve for c. It's simplified, but let's solve for c. And then we have the value, 37.71. That will be this value. Now, another one. We are looking for this measure, the measure of RS. We are looking for this angle. In this situation, we are looking for this angle that is here. Let's make the substitution. The arc length we are looking is corresponding with all the circumference as the measure of the arc that we are looking for, 360. Now, sorry, the RS is this part because we have the arc length in this part, that is 44. This 44 will correspond with this part. The circumference, we have to find it because we have the radius will be in substitution in this place, in 15.28. Now, we only have to solve for the measure of RS. Remember, the unit will be degrees. That is the final result.